On my screen, we have drill project 2 where we left off last session. And just to get an idea of where we left off, look at I'm going to go over a few things. We've got the level manager. It looks like we've created the wireframe from solid. The dimensions are present, or we've done the dimensions. The points are on their correct level. And we have a material. We have the material defined, and you see the solid model that represents the material on the material level. I'm seeing that the name level doesn't have any geometry on it. And this is going to be an additional step that we take with drill project 2. We did not do this with the first project, drill project 1. What we're going to do is we're going to place our initials somewhere on this face right here. And I'm not going to be too critical about the placement. This is just to help me identify who did the work. So we're going to place our first and last initial. I'm thinking somewhere like right here, and might be slightly different from last semester. But the placement isn't terribly critical. Once again, this is just a way for me to see who has done the work. So anytime we create something anytime we create some geometry, it goes on the current level. So I'm going to make the name level the current level. And I'm going to change up the color for the name geometry. The letters will be created from wireframe geometry. So I'm going to use the wireframe color. And I'm thinking this blue right here for now. And what we're going to do is we're going to create the letters or the initials slightly off of the part. And then we're going to reposition them on this top surface right here. Go to wireframe. And from the wireframe tab, at the top middle of your screen, you'll see an icon called Create Letters. Select Create Letters. It opens up a dialog box. And right away, you can see in the letters field, the icon is flashing. Let's type in your first initial and your last initial. And I'm typing mine in all caps. Once you type in your initials, and actually before we move forward, go to Style, expand this menu, and I'm going to use Mastercam box font. This one's pretty good for engraving, so Mastercam box font. Go down to the height. This is how we control the size of the initials or the letters. I'm going to use a font height of 0.25 inches. So I type in 0.25, I hit enter. And then when I move my cursor into the graphics area, you can see my initials attached to my cursor. Now, something that I can do while I'm in the graphics area, I haven't placed the initials yet. You could click and then come over here and hit enter again. Actually, it's making a liar out of me. What I'm going to do, I'm going to set my construction plane to 2D and have the Z value set to 0. And once I clicked on 2D, another instance of my initials appeared on my cursor. Down at the bottom of your screen, I want you to toggle it from 3D to 2D, left click on it. And then your Z value is set to 0. Right click on your screen, look at it from a top view. And what I'm going to do is I'm just going to visually approximate the placement of my initials. Once again, it's not critical. I'm just going to place them right here. Left click to place them. And then I'll select the green check to exit. And I'll do that again. I'm going to Control Z to delete the initials that I created. I'm going to look at it from an isometric view and change back over to a 3D construction plane. I'm going to start by creating the initials. I'll go to wireframe, create letters. For the style, select Mastercam box font. For the letters, type in your first and last initial. For the height, I've got it set to 0.25. Once you hit enter, move your cursor into the graphics area. I'm not seeing anything yet, but I need to click on the 3D construction plane. I want to change it over to a 2D construction plane. So if I click here, you can see it changes to 2D. And now you can see my initials attached to my cursor. If I look at it from a top view, so right click on your screen. From the flyout menu, select top. And then approximate the position. Now be careful, your auto cursor wants to lock on the things. So I'm just going to get close to where I think it looks good, right about here. Left click, and then select OK. Now what happened was when I changed over to a 2D construction plane and had the Z value set to 0, you can see my coordinate system sitting on the top of the part. So no matter what I create, what type of 2D geometry I create, it's going to be laying, or it'll be planar with this top surface. So that's why I changed over to a 2D construction plane. And once I place the initials, I'll just toggle back to a 3D construction plane. The majority of the time when I'm creating geometry, I'm using a 3D construction plane. In a situation like this, that's a useful tool to help place something on a surface. From here, I'll save my work. And you can now see on the name level, there are 11 entities. Now that might be a little bit confusing. You might have a different number of entities. It's very rare that we all have the same number of entities, if at all possible, because our initials, this particular tool, this wireframe, from the wireframe tab, this create letters icon, it creates initials, or creates letters, I should say, but they're not editable text. Once you create them, they are a done deal. So if you need to redo it, you have to undo or delete them and then redo the initials. What Mastercam is doing with this tool is creating the letters with wireframe geometry. It's creating with lines, arcs, once again, lines. I got an arc here, another arc here. And so there's actually three arcs right here. So depending on the font that you use, depending on your initials, the number of entities that it takes to create your initials, they're going to be all over the place. We're not going to have the same amount of entities. It's very rare that we do. And the nice thing about these initials, when they're made out of lines and arcs, we can use this type of geometry to drive a toolpath. And we're actually going to use this geometry to engrave our initials in the top surface of this part. So from here, I'll look at it from an isometric view. I'll flip my screen. And then I'll unzoom by 80%. And I recommend saving your work frequently. So how is everyone doing with that?
Good.
Good. Any questions related to what I just did?
Just confirming, it's okay to have different number of entities, right? You don't grade on that.
Well, on the initials, they're always going to be different because you've got BB, right?
Yeah.
So remember, you're going to have like a W, like an N. The letter N is going to have 3 lines, and yours is probably going to have a bunch of arcs and some lines. So there's going to be different numbers of entities depending on the initials.
Yeah, but like the other entity, you just delete duplicates and it should sync up, right?
The majority of the time. So let's say you have like an extreme amount of extra lines, or say your solid support geometry is, twice that of mine. What you can do is just go to home and then go to the delete section, delete duplicates. And if there's anything if there's like entities laying on top of each other, Mastercam will identify them as duplicates, and it will delete them if nothing is dependent on them. Does that make sense?
Yeah, copy that. Thank you.
You're welcome. All right. How's everyone else doing?
All good.
Nice. All right, cool. So from here, I'm going to go back to the project page. You just get an idea of where we're at. So modeling drill project 2. And there's an additional step. The creating of the initials is not in this list. I'll go back in and I'll update it. So next time that step will be included in modeling the part. So we created the bounding box to represent the solid of our material, and we saved the file. Now we're going to move on to creating toolpaths for drill project 2. Step 1, make the toolpath manager visible and import a machine definition. So I'll go back to Mastercam. Before I bring in a machine definition, we're supposed to make the toolpath manager visible. Go to View. In the Manager section, you can select toolpaths. And anytime you have multiple managers open, you access them from the tabs on the bottom over here. Bottom left of your screen, you see these tabs. So however many you have opened up, you'll see the tabs down here. You can't minimize them all. It's easy enough to bring them back. Once again, when I'm creating geometry, I like to maximize my graphics area, so I'll shut them all off. To turn them back on, there are hotkeys. If you hover over the icon, it says levels, Alt-Z. So hold the Alt key down, strike the Z key. That brings it up. It'll also make it minimize it. So Alt-Z again. But I'm in the habit of just going to View, Managers, and making it visible or making the manager visible this way. So Toolpath Manager is open. You can see that it's currently blank. I would like to add a machine definition to the Toolpath Manager. I'll go to Machine. In the machine type, go over to Mill. Expand Mill and select the default machine definition. And once you do that, you'll see the machine group appear in the Toolpath Manager, and we're going to need to make some changes to the default settings. Before I make any changes here, I want to set up my project folder, my project manager. Go to the File tab. Brings us to this screen. So File, go to Project Manager. Brings up this dialog box. Now, I saved this file to the class folder, and then inside of the class folder, there's a folder called Drill Project 2. So by default, the project file folder is where the Mastercam file is saved to. I would also like the NC files and the NCI files saved to this location. Now, you don't have the capability of creating these two files yet because you're working from home using the HLE, Home Learning Edition. It doesn't allow us to create these files. Once you bring your files to school, it will let you create these files. So even though we're not doing anything with these things yet, get in the habit of doing this. So from here, I'll select OK. To get back to Mastercam, I'll select the back arrow. Now ready to make some changes to the default settings of Machine Group 1. Under Machine Group 1, expand the properties, like the plus sign. You should now be able to see the files, tool settings, and stock setup. Select files underneath the properties. So left click on files, and it opens up this dialog box. The first thing I'll change is the group name. I want the group name to mean something. Help me clarify what's going on. So let's call this Haas VF2. And then we'll make a change to the spindle capabilities. Select Edit. Brings up this dialog box. You should see Mill Spindle Group. Expand this until you see Tool Spindle. Once you see Tool Spindle, double click on it. On this page, we want to set our maximum spindle speed to what our machine is capable of. So the three VF2s that we have at City College, we run those at 10,000 RPM maximum. I think they might be capable of going a little bit higher than that. But for whatever reason, they've decided that we're not going to run them any higher than 10,000. So set the maximum spindle speed to 10,000. And then select OK. That'll complete all the changes that we need to make on this page. So you can select OK again. And that brings us back here. That'll complete all of the changes that we need to make on the Files tab. How's everyone doing?
I have a question.
Yes, sir.
I remember last time we checked some boxes at the very bottom where it says output comments to NC file.
I didn't do that.
Oh, really? Oh, sorry.
Did you have another class with a different instructor?
No, I just thought we did something to have to do with like NC files or something. That might have been the.
No, that's this one right here. If you go to this guy right here, I think what you're thinking of is this. These guys right here. NC
Oh, yeah.
files and NCI files.
Oh, okay, yeah. Sorry.
Yeah.
Thank you.
Hey, no problem. No, so yeah, if I come back over here, some of the other instructors, whoa, here we go. We'll check these. I find these to add too much information and it causes some issues with certain types of machines. If there's too many lines of notes at the beginning of the program, it can throw an error. So I only use output operation comments to NC. I don't output any of this other information. So from here, we'll go to tool settings. The default program number, this will be the, it's also referred to the O word at the beginning of the NC file, program number, O word. So here you can enter a 4- or 5-digit number, and this will be placed or added to the top of the NC file as the program number. There'll be an O in front of it. We don't put the O in front of the program number here. Mastercam will do that for us. So 4-digit number of my choice, could be 4 or 5. If you're if you're programming for a Haas, try to steer clear of using 9000 series numbers. Those are usually locked out and reserved for other things on the controller. So I'm just going to call this 7501. The number that I just made up. Feed calculation. Let's take that from material. Toolpath configuration. Let's check assign tool number sequentially. Let's check warn of duplicate tool numbers, and let's check use tools, step, peck, and coolant. Once you do that, go down to sequence number. Let's start at 1 and then have them numbered in increments of 1. And this is how we control the line numbers on the lines of code inside of our NC file. Next, go to material. We need to start by setting the material. If I go back to the project page or the drawing, and let's see here, the material is not specified. And in this particular case, I'll make a change to this. I'll update it so there's no guessing here. We're actually going to machine this out of aluminum 6061. So I'll go back to the project page. Currently, the current material is aluminum inch 2024. Let's change this to aluminum 6061. So I'll start by selecting the select icon. From the material list, there's not much available, so let's access the library. Right-click in this field. From the flyout menu, select Get from Library, and then select aluminum inch 6061. You can double click on it or select it once and then select the green check. You can now see that it's selected. Select the green check again. And then you can now see that it's the current material. Once you have the material set to aluminum inch 6061, you can select edit. And if you need to, if you need to be more specific on the material name, let's say we just wanted to call it aluminum. That's wrong icon. Let's say we just wanted to call it aluminum 6061-T6. So once you rename the material or set the correct material, Go to base cutting speed. Let's set our base cutting speed to 300. And then go down to the percentage of base. And for drilling operations, it's currently set to 60. Left click on it one time. It changes to this blue color, hit enter. You can now change the percentage value. Enter 50 and then hit enter. So now the base the percentage of the base for drilling operations is 150. It's 50% of the base cutting speed of 300. So this will be the only change that we make on this page. From here, I'll select OK. We're going to go to stock setup. Stock plane is set at the top. For the shape of the stock. Now, this is how we define the shape of the stock inside of Verify. Now, remember, there's 3 definitions or 3 representations of the material in this section, in this session of Mastercam. There's going to be the solid model that represents the material. There's going to be the material inside of Verify, and then there's going to be a stock model that represents the material. So 3 separate things going on. We're going to have to just with time, we'll figure out, or we'll be able to differentiate between the 3. So for the shape of the stock inside of Verify, I'm going to use solid. And then if I select this icon, it allows me to pick select something on my screen that represents my material. Now be careful here. I don't want you guys selecting the solid model that represents the part. I want you selecting the solid model that represents our material. To do that, I'm going to bring the level manager back up. I'll go to view, managers, levels. On level 6, I have my material, the solid that represents my material stored there. So make it visible. And just so I don't accidentally select it, I'm going to make the solid model level invisible. You should now have a solid block visible on your screen. Mastercam is still waiting for me to select the solid that represents my material. So I'll pick select the material solid. And once I do that, you'll see these dimensions match the dimensions of our solid, or the solid that represents our material. To double check the placement of it, I can select display. I'll select solid. And then I'll select OK. And what's happening is there is a representation of the material. This is the material that we'll see inside of Verify. And it's currently overlaying the solid model that represents my material. And it's changed the solid model to this orange color. To toggle out the visibility of that, of the material or the stock display, just go over to toolpaths and click on this icon right here, stock display.
I have a quick question.
Yes, sir.
When you're looking at the stock setup, yours showed under the display solid, and mine's only showing wireframe and shaded.
Okay, let me
Is there
take a
any
look
difference?
at it real quick. I'll take a look at it. Hold on one second. So you're only seeing wireframe.
And then it says shaded underneath that is my only toggle option.
Interesting. Which version of Mastercam are you running?
Whichever one was
Okay.
the link through the site.
Okay, cool. May I see your screen?
Sure.
Let's see what we're dealing with here.
And share.
Mine shows the same. No solid.
Okay, not a problem. Let's see here. Go to see the icon that says so the solid icon, go up. It looks like your cursor. Click on that. Yep. Now pick select that and display. Interesting. So, and you're dealing with Oh, I know why. You've got a later version. Yours is correct. There's nothing wrong with it. You're on 2022. You're on the latest and the greatest version of the software. I'm on 2021. So this is one of those subtle differences that you probably never notice until you're working side by side with somebody. Does that
Okay.
make sense?
Yeah.
Yeah.
that
So
makes
yours is fine. So yeah. So instead of solid, they say shaded.
sense. Okay.
Cool.
Easy enough. Thank you.
You're welcome. Learned something new today. Like that. All right. All right, cool. So I come over here, turn this off. Yeah, and if I go back to stock setup, so the new one, instead of saying wireframe and solid, it says wireframe and shaded. Why they changed that, I don't know. But that's the only difference on that whole page, right? Interesting.
Yeah.
All right, so from here, I've got my stock display overlaying the solid model that represents my material. It's kind of changing the color of things. And all I'm doing is checking to make sure that's in the correct location. There will be times when you go into verify and the stock is off of the part, it's shifted off of the part. So I like to find out those things before I actually go into verify. So from here, I'm on the toolpath tab. Make the stock display or turn to stock display off. I'll go back to the level manager. I'll make the solid model that represents the part visible. I'll make the material solid invisible. I'll go back to the toolpath manager. One last thing we need to do prior to creating stock models and creating toolpaths. Let's rename toolpath group -1 to something that's more meaningful. This is a generic name. It's kind of like machine group -1. This is toolpath group -1. I'm going to rename toolpath group -1 to first operation. Left click on it. Right click from the flyout menu. I'll go to groups. Rename. I can now rename toolpath group -1. I'll call it first operation. And I'm now ready to start creating stock models and toolpaths. How's everyone doing?
Good.
Nice. All right, so from here, let's start by creating the third representation of our material. And this will be the stock model. And the stock model is going to be dependent on the solid model that represents our material. So let's do this. Insertion arrow, this is the red insertion arrow. It can actually be above it, but we want it below the first operation. This is where the stock model or the toolpath will be inserted. Go to the toolpaths tab. In the stock section, select stock model. And this is going to look like this will be the material prior to any machining operations. Let's start by giving it a name. We'll call it raw material, raw stock, something like that. So raw stock. Stock plane, I have it set to the default at the top. Now I have different ways to define the initial stock shape. Because I have a solid model that represents the raw stock inside of Mastercam, that's what I'm going to use. So for the initial stock shape, I'll select model. The cursor that looks like the icon. I'm sorry, the icon that looks like the cursor, I should say. Select that icon. That allows me to go back into the graphics area. Once again, go to your level manager. Make the material level visible. Make the solid model level invisible. Pick select the solid model that represents the material. Once you select it, select end selection. And it's not showing me any indication what it is, but I think we're good. And that's all we need to do at this time. So for the initial stock shape, we're just going to give it a name and then pick the solid that represents the material. I'll select OK. And once again, the material representation appears on my screen. I'll turn off the material level. The gray thing that we're currently seeing, that is the stock model. We access that through the toolpath manager. Go to toolpath manager. The way we toggle off the visibility of the stock models, the same way that we would toggle off the visibility of the toolpath. Select this icon right here. Toggle display. And once you turn it off, you can see now it looks like a wireframe view. But you can also notice that there's this folder under the stock model changes in its appearance. So no diagonal lines, the stock model is visible. Diagonal lines, invisible. I'll go back to the level manager and I'll make the solid model that represents my material visible again. How's everyone doing?
Yeah, I don't think I triple clicked correctly. You're supposed to triple click. I only got one face.
Not that time. You only had to pick it one time. The triple click is for when we create the curves on all edges. In this particular case, all you gotta do is left click on it one time and then hit the green check.
Yeah, the only thing is when like it didn't go, it only turned the top face gray versus the whole.
May I see your screen? Once again, you're using a slightly different version of the software than I am. So let's see what you got going on. One second. Okay.
You have to triple click.
So make the material level, make the solid model level invisible. Okay, now go to your toolpaths. Hit the regen, hit the fourth icon from the upper right, upper left. One more over. Okay, click on that, please. I think you're good.
Oh,
Toggle off the display. So with that selected, I think you're good. Yeah, just upper left, the three wavy lines. Yep. Click on that. So that toggles the display on and off. Yours looks a little different because you have translucency turned on. The icon at the very bottom right of your screen. So it's going to look a little different with translucency. There you go. That's a little bit right there. Looking good. All right, cool. So all good?
yes, sir. Thank you.
You're welcome. All right, go back to my screen. Okay. So from here, I'll go back to the toolpath manager. Now, I think I've gone forward with a few of the steps without actually referencing the project page. So let's go back to the project page and see what we were instructed to do. See if I missed anything. All right, that's the modeling. And here's the creating the toolpath. So step one, make the toolpath manager visible, import machine definition. We've done that. Step two, modify the settings. Did that. Step three, the drill toolpath. Use the drill toolpath to create pilots for all drilled holes in the part. So that's where we are now. And before I do that, let's talk about the tools that we have available to us. Going all the way to the bottom of the project page, tool one. This is a 1/2 inch diameter spot drill, 90-degree DPA. We're instructed to use a C4C3-0032 tool holder, and the tool projection, some people call it stick out length, is 1.5 inches. And so we'll do that. We'll create a drilling operation. We'll bring in the 1/2 inch diameter spot drill, and the spot drill is going to accomplish two things. We're going to use a spot drill to create the 0.35 countersink at the top of the holes. And it's also going to be used to help guide the 0.3125 diameter drill. So spot drills is going to actually be two operations. When you have a regular length drill, sometimes people call them jobber drills. If you try to drill a hole without some type of guide or some type of pilot, the drills have a tendency to wander a little bit when they come into contact with this, with the surface. And in certain cases, you can the hole will be drilled oversized. You could damage the drill. You could scrap the part. So we're going to use this pilot drill, spot drill in this case, to create the pilots for the 0.3125 diameter holes. So I'll go back in the Mastercam. I'm looking at the toolpath manager. Once again, the insertion arrow, you want this at the very end. I'm going to go to the toolpath tab. In the 2D section, select drill. We're instructed, we're given several instructions on how to go about selecting the geometry. What I'm going to do in this case, I'll select this icon, mask on arc. It says select an arc from the graphics window. Mastercam selects the center points of the arcs with matching diameters. So watch how this works. I'm going to select this icon. I'm going to come over into the graphics area. I'm going to select the 0.35 diameter circle that's on top of the part. And in this case, I'm selecting the one that's closest to the origin. Left click. It doesn't appear if anything has happened, but this prompt has changed. It says use window select, Control A, or the arc quick mask to find matching arcs. You could window select, you could select Control A, or you could use this icon right here, select all arc entities. And it's only going to select the arcs with the same diameter at the same Z level. So if I select this icon right here, select all arc entities, left click, all matching circles become selected, and you can see how they're chained together. The red point represents the first hole that will be drilled. The lines are showing the order that the holes will be drilled in. And in this case, and then there'll be a hole drilled where each of the points are located. So you get an idea of what's going to happen before we even see the toolpath. Now, the order that they're being drilled in, let's say for whatever reason you don't like the order that these are being drilled in, you can come down here and where it says sort, expand this menu. And where it says 2D sort, you can get an idea of how these things work. Once again, the red point is the first hole to be drilled. And then you can see the lines showing the order that they'll be drilled in. Let's say for whatever reason, now this isn't necessary, but let's say for whatever reason, this had to be the first hole to be drilled. That's just the way you wanted it. I'm going to use this one right here. I'll select it. And you can see how it changed the first hole to be drilled and the order that they're being drilled in. Once again, it doesn't have to be this way, but you have options for whatever reason. So in this case, I can now see that this is the first hole to be drilled. I can see the order that they're being drilled in. I like what I see. So from here, I'll select the green check. And that opens up the parameters for the drilling operation. How's everyone doing?
I have a question.
Yes, sir.
Can you remind me exactly where you clicked after you selected mask on arc?
Oh, I didn't click anywhere. Hold on, I'll do it again.
You didn't-
Let me show.
Okay,
So-
sorry.
So I'm here, right?
Yes.
So it says I select here, I go, it says mask on arc. Now the prompt is select an arc to match. So I'm going to select this 0.3 diameter circle at the very top of the part, the one that's closest to the origin. As I position my cursor close to it, you see how it becomes highlighted, indicating to me if I left click at this time, it's going to become selected. Now, the prompt is telling me, it says use window select, Control A, or the quick mask arc, quick mask to find matching arcs. After this, all I did is select this icon right here, the upper left half of it, and it selected all matching circles. Does that help?
Yeah, it won't let me select the line itself. It just wants me to select the top of the part, like the whole plane. I'm
May I see
thinking
your, may I see your screen real quick?
Yeah, sure. Sorry.
No problem. Okay, select an arc to match. Okay, so zoom into the one that's up the upper. Select that. Oh, interesting. Okay.
Maybe I'm looking at like the wrong.
No, go to your
level.
level manager. Do me a favor, grab the left edge, I'm sorry, the right edge of the tool, yep, drag it over. And let's see here, where's your wireframe? Okay, your wireframe from solid, it's visible. Do me a favor, make the wireframe from solid the active level.
Mhm.
And then make the solid model level invisible. Okay, now let's try it. Now click on that. Yep. Now it says use
Okay.
window. Now try Control A. Looks good. So
Okay.
for whatever reason, it was locking onto or it was highlighting faces on the solid model. So in that particular case, and this is why it's real nice to have things on different levels. While you're in the middle of a command, you can go to the level manager, you can make things invisible. You see how that worked?
Yeah, I see that. Okay.
All right, cool. So I'm gonna go back to my screen.
Thank you.
Welcome. Okay, so now, actually I'm okay here. Brings us back to this page. And you just saw how I could go back in. I go back to this page right here. I deselected or removed all selected points, and then I went back in and selected the points again, or I could have selected different points. So from here, I'll go to the tool. My tool list is currently blank. We're going to add a 1/2 inch diameter, 90-degree spot drill. So I'll go to select library tool. My filter is still active from the last time that I used Mastercam. So in this particular case, you want to have filter active checked. Select the filter icon. And I'm looking for a drill. There's a good chance you have all tool types selected. So what I'll do in this case, I'll start by selecting none. And then I'll select the type of tool that I'm looking for. And in this case, I'm looking for a drill. You can see that the tool diameter filter is active. Let's set this to equal and then type the decimal equivalent of the tool in this field. Now, in certain cases, you won't know the decimal equivalent, so you can type in a fractional value, 1 divided by 2. You could type in a wire size. Not necessary that you do this. I just want you to be aware of it. So if I typed in a wire size, it would be #3. Say a number 3 drill or a number 7 drill, hit enter. Or a letter size drill, let's say #X 0.397. So it knows you don't necessarily need to know the decimal equivalent. You can type in the letter size, wire size, or fractional value. In this particular case, it's a 1/2 inch, so 0.5 is pretty straightforward. I'll select OK. It's filtered out every tool but the one that fits the description. So I've got one tool. It's tool 162. This is 162 coming out of the library. Watch what happens when I double click on it. It's added to my tool list as tool number 1. You'll remember we checked assign tool number sequentially under the tool settings here. If it's coming in with the same number that it has in the library or the catalog, you don't have that checked. So I've added the 1/2 inch diameter drill to my tool list. It's tool number 1. To edit the tool, I'll right click on it. From the flyout menu, I'll select edit tool. This will take a moment. All right. On this page, things that we're going to change. Oh, my bad. We all have to back up a little bit. This is a jobber drill. So cancel. Let's delete this one. So select it and then hit the delete key. I led you guys down the wrong path. So let's start from scratch. So I deleted that, go back to select library tool. Go to the filter. Deselect drill, and then select the one right below it, spot drill. The tool diameter equal to 0.5 will still work. I'll select OK. Now tool 24, 1/2 inch diameter spot drill, double click on it. It should be added to your tool list as tool number 1. To edit the tool, right click on the tool. From the flyout menu, select edit tool. Some changes that we'll make on the first page. Set the cutting length to half the tool diameter, so 0.25. And then for the shoulder length, set that to 1. And that'll complete all the changes that we need to make on this page. From here, select next. On this page, to get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, select the calculator icon. We're going to have a RPM of 1,146. From here, we can turn on the coolant or cutting fluid. So select show more options. Select the coolant icon. And let's set the flood coolant to on. So flood from the flyout menu or drop down menu, select on. And this will create the M8 command or code inside of our NC file. Coolant on. And then from here, select OK. That'll complete all the changes that we need to make to this page. So from here, select finish. How's everyone doing?
Good.
Nice. All right. So the RPM was calculated based off of the 150 SFM. The feed rate. We need to calculate our feed rate. To do that, we're going to enter the feed per revolution. Think of it as that the FBT as feed per revolution. Set this to 2% of the tool diameter. To do that, I'll usually just enter the decimal equivalent of the tool, so 0.5, multiply by 0.02. That sets my FPR, FPT, or FPR to 0.01. And that creates, or that calculates the feed rate at 11.46 inches per minute. From here, go down to the comment field. We're going to provide some type of useful comment. So I usually start by just borrowing the tool name. So highlight the tool name, right click copy, and then down in the comment field, right click paste. In all caps or all capital letters, type in some type of comment that'll be useful to us out of the machine. So drill all pilot holes. That'll complete all of the changes on this page. From here, go to the holder. Now this default holder, it looks like a puck, not much to it. It's not a very good representation of what's out at the machine or what we're going to actually use. So if I go to the project page, go all the way down to the bottom, I'm going to reference the tool list here. For the tool holder, use a C4C3-0032 and the we're using 1.5 inch tool projection. There's a long list of tool holders here. So what I can do, I know I'm looking for a Cat 40 inch tool holder. I'm going to look in that folder. So I'll go to Open Library. Inside the Cat 40 inch, so CT40-IN, open it up. And in this particular case, the C4C3-0032, it's the third one down. This is a better representation of what the tool holder is going to look like. At my shop, we have ER32s, Cat 40 ER32. So this is what I would probably hold on to this tool with. Tool projection. We're instructed to set the tool projection to 1.5 inches. And that's a decent representation of what we would see at the machine. How's everyone doing?
If your toolpath type is not green checked at the top left, is that an issue?
Maybe not, maybe. The reason it's checked up here. Usually it's an indicator that you made a change here. But the only change that I made was I reselected the geometry. So I can't recall if that green check was there prior to me doing that. It probably won't be a big deal. If there's an issue inside a backplot, if you don't see anything, then we'll address it. Is that all right?
Yeah, sure.
All right, cool. All right, so from the holder, we're going to jump down to cut parameters. Now there's a lot of settings here. Some of them I've never touched. There's just a lot of bells and whistles, and not all of them need to be adjusted. A lot of times the default settings work perfectly. In this particular case, we're going to adjust maybe 4 or 5 of these settings. So from here, I'm going to jump down to cut parameters. I'm not going to change anything on this page. I'm just verifying that the cycle is set to drill / counter bore and the dwell value is set to 0. If there's any information here, set it to 0 and then select this icon right here, save parameters to default file. Then select OK. So the difference being is if there's a value here, it's going to create a drilling cycle at G81. If there's no value here, it's going to create a drilling cycle at G81. If there is a value for dwell, it's going to create a counter bore cycle or a G82. In this particular case, we're just creating a pilot, so I want this set to 0. And that is what I'm checking. From here, go down to linking parameters. Z0 is the top of the part. So I'm going to set a clearance plane to 2 inches absolute. And then I'll check use clearance only at the start and the end of the operation. For the retract, I have it set to incremental. Change the value to 0.1. Top of the stock, I'll set it to absolute. Now remember, top of the stock, that's where the origin's at. So that is set to 0. For the depth, I'll set it to absolute. And I'm going to have Mastercam calculate the depth. What I'm going to do is I'm going to create a countersink equal to the outer diameter of the chamfer. So I'll select this icon. I've got it set to absolute, select the calculator icon. I'll start by checking or selecting overwrite depth, where it says finish diameter. On the blueprint, it says create a countersink. Here we go. This symbol right here represents countersink, or means countersink. And if you zoom in, and you can see it on our model, that there are 2 diameters, or there's a chamfer on that edge. So the outer diameter, the bigger diameter is 0.35, and that's what we're going to create with this spot drill. Then the smaller diameter is the hole that goes all the way through the part. That's 0.3125. Now, 0.35 is a pretty easy number to work with, but I wanted to show you a tool inside of Mastercam. We can let Mastercam calculate the depth based off of the circle that represents the diameter of the countersink or the chamfer. To do that, where it says finish diameter, click in the field, right click, and then from this flyout menu, select diameter of an arc. Left click. That allows us to go back into the graphics area. Now, Brian, I think you might have the same problem that you had earlier. Now, as I position my cursor, you see how the certain things highlight, you'll see an icon pop up next to my cursor. Right now, if I left click, it's going to select the surface or the face. Here, you see how it's kind of there. Okay, that's the surface again. But if I get closer here, you see that edge? It's a line with an E next to it. If I select it now, it picks up the diameter value of that edge or that circle and places it here. And it's going to calculate the depth that it needs to drill to based off of this information. From here, I'll select OK. It's going to drill to a depth of Z minus 0.175, creating a diameter of that countersink of 0.35. One last thing that I'll need to check where it says tip comp, make sure that this is turned off. You see the circle with the diagonal line, the red circle with the diagonal line going through it. That's an indicator that it's turned off. So turned off. From here, I'll select OK. You should see a toolpath appear on the screen. Now, initially, it looks like lines, but what it's showing us is it's showing us the path that the center line of the tool is going to take, or the center of the tip of the tool, I should say. Now, there's actually some meaning to the colors assigned to these lines. The yellow lines represent rapid moves. They're going to travel, the tool's going to travel along these lines as fast as the machine is capable of. The blue lines represent feed moves. And the feed that we calculated was 11.46 inches per minute. So that's an indicator of that's what these lines are telling us. The color of these lines are telling us the difference between a rapid move and a feed move. So things that I'll look for while I'm at this stage, I'm looking for yellow lines moving through the material. I'm looking for blue lines that are going too deep. And everything's looking pretty good so far. So from here, with just that toolpath selected, I'll go to this icon right here, backplot selected operations. There are things that we can do to control what's visible on our screen. This particular icon here, I can control the display of the tool. I can control the display of the tool holder. I can control the display of rapid moves. And I think feed moves are on here somewhere too, but not seeing an icon for them. So I like to have the rapid moves visible. I like to have the tool visible, and I like to have the tool holder visible. To play the backplot, or to play the animation inside of backplot, here I have my play controls. You can control the speed. I'm going to set it about at a quarter. And then I'll select play. Now that's a little slow. I'll speed it up. Now I can see what the toolpath is going to look like at the machine. I'm not seeing any issues with this toolpath so far. So from here, I'll exit out of backplot. I'll select this X right here. I'll toggle off the visibility of the toolpath. So while it's selected, if you select this icon, turns off the visibility of the toolpath. I would like to run it and verify. This gives us that extra level of it double checks at a higher level for any issues that we might have. So from here, I'll save my work. I like to look at it from an isometric view. I like to fit the screen. Then I select unzoom 80%. You can select the entire first operation toolpath group. Even though the stock model is selected, it will not appear inside of verify. So I usually just click the entire first operation toolpath group. And then the icon next to verify, the icon next to backplot is verify. So select verify. That'll open up a new window. Once I'm inside of verify, I always want to take advantage of the stop condition collision. If there's a crash, it'll stop inside of verify, and it could save us a lot of grief from, if it gets out to the machine, we've got problems, but this can save us a lot of grief. So from here, where it says stop condition, I'll select collision. There's a green check. I'm sorry, there's a check next to it. From here, I'll select play. Went through it kind of quick. You can rewind it. You can slow it down a little bit. Depending on your computer, sometimes it just has a tendency to jump forward and you don't actually see the animation. Looks decent. what I'll do is I'll zoom in and I'll compare the wireframe model, which is visible, to the machine model. And in this particular case, the outer diameter of the countersink should match the diameter of the circle that we drew in to represent the countersink. So everything's looking good. If you, the closer you zoom in, it does get a little choppy. That's just the limitations of the graphics. You can increase the precision, but that will slow your computer down. Sometimes it'll even make it crash. So once I verify that the toolpath looks good inside of verify, I'll exit verify. Once again, isometric view, and I'll save my work. So now that I've created the pilots for these drilled holes, I'm going to create the stock model that will show what the part will look like up to this point. Make sure the insertion arrow is at the very end of the toolpath group. Go to the toolpaths tab. Under the stock section or in the stock section, select stock model. For the name, let's call this one pilot holes or something else that makes sense. This one does not need to be all caps. So pilot holes. Stock plane, I'll leave it set to the default top. For the initial stock shape, this time I'm going to use the stock model that we created that represents our material. So for the initial stock shape, select stock model. And the only one that's available at this time is raw stock, so I'll select it. That'll complete all the changes that we need to make to this page. From here, I'll go to source operations. And I'm going to select the drilling operation that we just created. From here, I'll select OK. And it takes Mastercam a moment, but now I can see that there's a stock model that has the pilot holes drilled in it. Now, I believe I demonstrated this last class or demonstrated this to you guys last class. If I change anything, if I make the countersinks deeper or shallower, the stock model will update and it'll show us exactly what this toolpath is doing to the part. So like inside of verify, I'm going to verify that, make sure that it's correct. And once I'm satisfied that the stock model is correct, I'll toggle off the visibility of it. So with it selected, I'll select toggle display. From here, isometric view, and I'll save my work again. The next thing I need to do, if I go back to the project page, let's see here, step 4, use the drill tool path to create the holes in the part. If I scroll down, the tool list is telling us to use tool number 2. It's going to be a 5/16 diameter drill, 0.3125 in diameter, 118 degree DPA, that's drill point angle. We're instructed to use a C4C3-0032 tool holder, same as before, or same as the previous tool. And this time the tool projection will be 2 inches. So from here, I've got enough information to go back in the Mastercam. Insertion arrows at the very end of my toolpath group. I'm going to go to toolpaths, 2D, drill. Brings up the toolpath hole definition dialog box. Once again, I'm going to use this icon, mask on arc. Select it. This time I'm going to select the circle that represents the hole that's going all the way through the part. So I select it. It says use window select, Control A, or the arc quick mask to find arc matching arcs. I'll select the quick mask icon. Now this one's got me a little concerned. We'll see how it looks like, and we'll see what it looks like inside of Backplot. We might change the geometry that we're driving the toolpath with. So what I don't like is I'm seeing the yellow line that's connecting the holes running through the part itself. So that could be a problem. I think we can control it with the linking parameters, but we'll find out for sure when we go into Backplot. So first hole to be drilled is identified by the red point. And then the order that they're being drilled in, you can follow the lines that are connecting the points. From here, I'll select OK. I'll go to Tool. Now, Brian, were you asking me the question about the green check next to the toolpath type?
Yeah.
Okay, so you see how I don't have the green check next to it?
Right.
And usually, if there's no check next to it, my understanding is that means you didn't do anything to the default settings. So let me do this real quick. So there's no green check here. Last time I deselected the points and then I reselected them, and then look what happened. So that's just an indicator. That's just a way for us to check if we did something on that page. Does that make sense? So in this particular case, I deselected the geometry. I need to reselect it now. So I'll select that circle. My bad. Okay, so I'm back to where I started. And I got too much information in here. So let's see. Delete all. Control A. Okay, I'm good. Green check. And the same thing. So I've got this, there's nothing different going on, but it's just a way for me to track a page that I might have made a change to. Does that make sense? And I'll be honest with you, I didn't really take note of that before. So that's what I think is going on here.
Yeah, you know, I think it's a version. It's probably a moot point, but like in my version, it says machining geometry 12. And then below that says solid model and avoidance geometry 0 and 0. It doesn't have arc geometry or point geometry listed like yours.
Yeah. So once again, that's what one of those subtle differences between 2021 and 2020. So yeah, it's not going to be an issue. There are some differences, but nothing that's really going to affect what we're doing. I don't want to update the 2022 because then I'll lose the ability to create the NC files. I don't have the my sim or my hasp, whatever you want to call it, or my dongle, whatever they refer to it as. Mine hasn't been updated since we shut down for COVID. So I can't download the latest version of the software at this time with the license that I'm using. So please bear with me.
Gotcha.
All right.
Yep.
With that said, Corey, are you out there? I'll talk to him about it a little bit later. Okay, so from here, I'm going to go to the tool. I'm going to add another tool to my tool list. Select library tool. This time we're going to add a 5/16 diameter drill, so I'll go to the filter. I'll start by selecting none, and then I'll select drill. For the tool diameter, set it to equal 5 divided by 1/6. I hit enter. It shows us the decimal equivalent. So drill equal to 0.3125 in diameter. I'll select OK. It's tool 137 coming out of the library. If I double click on it, it's added to my tool list as tool number 2. To make some changes to the default settings, I'll right click on the tool, and from the flyout menu, I'll select edit tool. Now, if I remember correctly, we were told to use a tool projection of 2 inches. So something that I'll do here, make sure the cutting length is 2 inches, and then I'll set the shoulder length to 2 inches. Mastercam will only let us hold on to the dark gray part. In reality, you could hold on to more, but that's just the way Mastercam works. So I'm setting the dark gray so that it's 1 inch in length. The overall length is 3, cutting length is 2, shoulder length is 2. I could set this to 1.75. I think that would be, nope, other way around. So this is 2, and this is 1.75. What the limiting factor here is that the Mastercam will only let us hold on to the dark gray part of the tool. So that's why I'm changing these values. So from here, I'll select next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, select the calculator. The spindle speed or the RPM is 1,833. I can also turn the coolant on. I'll select this bar or the show more options icon. I'll select coolant. And then I'll set the flood coolant to on. And then I'll select OK. That'll complete all the changes that I need to make on this page. So from here, I'll select finish. We've already calculated our RPM. We need to calculate the feed rate. To calculate the feed rate, we need to come up with the FPR or the FPT. For drills, it's FPR, so you need to think of this as an FP. Think of this FPT as FPR. Set this to 2% of the tool diameter. The decimal equivalent of the tool is right here, 0.3125. So in this field, I'll type in 0.3125 times 0.02, 2%. When I hit enter, it calculates what the feed rate is. The feed rate is the RPM multiplied by the FPR. So 1,833 times 0.0063 gives us 11.46 and whatever this calculates out to be. From here, provide a useful comment. I'll start by copying the name. I'll paste it in the comment field. And then all caps. Say drill all holes through. And that'll complete all of the changes that we need to make on this page. From here, I'll go to the holder. We're using the same tool holder as the previous tool. I'll go to open library. I'll open up the Cat 40-inch tool holder library. So CT40-IN. Open it up. We're looking for the C4C3-0032. And then we're instructed to set the tool projection to 2 inches. That completes all of the changes that I need to make on this page. From here, go to cut parameters. When we selected a jobber style drill or a regular type drill, it changed over to a peck drill cycle. The peck increment is equal to the drill tip length. Once again, that value is a default setting. It's coming from the setting that we checked, use tools, step peck and coolant under tool settings. So from here, go to linking parameters. When you use a like toolpath to something that you've already used in a session of Mastercam, Mastercam likes to hold on to the settings from the previous tool. So you'll see here that the clearance has already been set to 2 inches absolute with use clearance only at the start and the end of the operation checked. Retract is set to 0.1 incremental. Once again, this is from the previous toolpath. This is all good. Top of stock, 0 absolute, good. The depth, I've got it set to absolute. This time, what I like to do is I like to pick off a piece of the geometry to identify the Z depth that we're going to be drilling to. So from here, I'll select the depth icon. It allows me to go back into the graphics area and I can pick select something that I can lock onto that has a Z value that I'm looking for. And it's hard to see, but I would like to pick on the center of the circle that represents the bottom of the hole. Now, I'll change over to a translucent view. And you can see where the full diameter ends, and then you can see the profile of the drill tip. I want to let my cursor lock on to the center of the circle that represents the bottom of the hole, not the tip of the drill profile or the drill tip profile, but the bottom of the hole. When I see it lock on, left click, it's providing or enter the value of Z minus 0.625. This is where we're telling the bottom of the holes, or this is where we're telling how deep to drill to. I need the tip of the drill to go down to here, or I need the full diameter of the drill to go to this depth. So what we're gonna need to do is we're gonna need to turn on tooltip or tip comp. And to do that, come over to this, the setting underneath linking parameters, tip comp. To turn it on, select the check next to tip comp. And what this is going to do is going to add to the depth of the hole that's being drilled. I don't want any additional breakthroughs, so I'll set this to 0. And then I'll let Mastercam calculate the additional Z depth based off of the drill tip angle. From here, I'll select OK. I can see a preview of what the toolpath will look like inside of Verify. I'm sorry, inside of Backplot. So now with just the new drilling cycle selected, you can see a green check next to just that toolpath. I'll go to Backplot. And if I hit the S key, you see how it's going through the motions. But what I would like to do is I'd like to look at it from a front view. So right click, front. Now if I zoom in, it's not easy to see. If I change over to a wireframe view, that's a little bit better. And what I'm checking, I want to make sure that the profile of the drill tip goes all the way down to the bottom of the drilled hole. And there you go. And you can see the full diameter matches up and the drill tip matches up with the profile of the hole. And that's what I'm checking for here. And then once I verify that that is correct, I'll just select play, go back to a shaded mode, and then I'll let verify run out. Or I should say I'll let Backplot run out. So I like what I see. I'm not seeing rapid moves going through the part. When it repositions itself, it's got plenty of clearance, so I like what I see. So I'll exit out of Backplot. To toggle off the visibility of it with just that toolpath selected, I can select toggle display. I'll look at it from an isometric view. I'll fit my screen. I'll unzoom 80%. And before you go into verify, before you verify your toolpaths, I highly recommend that you save your work. So file save. I'll select the entire first operation toolpath group. There's a green checks next to everything. Don't worry about the stock models being selected. They will not appear inside of verify. So from here, I'll select verify. Stop condition, collision is turned on. And then I'll select play. When verify is done, I'll tumble my view. I'll zoom in. And once again, I'm just comparing the wireframe representation of the part to the machined model inside of verify. And everything appears to be lining up. I like what I see. I don't have any collisions. So once I verify that everything is good once I verify that everything is good with the toolpath, I can exit verify. And this is redundant, but once again, I'll save my work. So now that we've created the second drilling operation, we need to create the stock model that represents everything that we've machined on this part so far. The insertion arrow is at the very end of the toolpath group. I'm going to go to the toolpath tab. In the stock section, I'll select stock model. For stock definition, for the name, let's call this drilled holes. For the initial stock shape, once again, we're going to use a stock model. I'm going to use a stock model from the previous operation. So I'll go to stock model from the drop-down menu. I'll select pilot holes. From here, I'll go to source operations. And then I want to select the drilling operation that we just created. From here, I'll select OK. Now, the stock model looks exactly like the solid model, or it should. If I go to the levels manager and make the solid model level invisible, this gray representation of the part, this is the stock model, and it's showing us what the part will look like after the 2 drilling operations. And I like to inspect it like I would I inspect it like I inspect the machined model inside of Verify. I just want to make sure everything's there. You can see the edges line up. It looks good. Once I verify that it's correct, I'm making the solid model level visible again. From the toolpath tab, I'll make the stock model invisible. And once again, I'll save my work. So something that we're adding to this project that we did not do on the first project, we're going to engrave our initials on the top of the part. If I go back to the project page, step 4, use the drill toolpath to create the holes in the part. We just did that. Step 5, you use the contour toolpath to engrave your initials in the part. Okay, let's do that. I've got these initials that are built from lines and arcs. We can machine lines and arcs. We can use that geometry to drive our toolpaths. I'm going to go to the toolpaths tab. In the 2D section, we're going to use the contour toolpath. Select contour. And that brings up a thing called the wireframe chaining dialog box. Now yours might look a little different than mine. For mode, I've got it set the wireframe. Below that, you have C-plane or 3D. Set it to C-plane. And then for the selection method, I have chain selected. So mode is set to wireframe, C-plane is selected, and selection method is chain. I'm going to look at it from a top view. Then I just remembered something. So zoom in, looking at it from a top view, and I zoom in. I'm rolling my scroll wheel, getting close. The way I'm going to select this is different than I was thinking. So mode is set to wireframe. Instead of C-plane, I want you to select 3D. And then for the selection method, we're going to use window. So wireframe, 3D, window. Now watch how I do this. I'm off of the part. This window selection will only select things that are completely within the selection window. So watch how I do this. I do a window select. It's asking me to sketch an approximate start point, but there's nothing there because it didn't capture everything. This window, I'm going to left click and drag. And I want to have my initials completely within the selection window. And once you get that, the window large enough to capture your initials and nothing else, left click again. It doesn't look like anything has happened. But if you look at this prompt, it says sketch approximate start point. Let your cursor lock onto the bottom left point or bottom left endpoint. And when you see it lock on, left click, then all of the geometry that your initials are created from becomes selected. From here, I'll select OK. And that brings up the parameters for the contour toolpath. I'll do that again. So mode is set to wireframe, 3D is selected, selection method is window. I'm going to create a window, left click and dragging the mouse. I create a window around my initials, left click to complete the window. And now Mastercam is asking me to sketch the approximate start point. I'm letting my cursor lock on to the bottom endpoint. When I see it lock on, left click. The lines and the arcs that make up my initials are now selected. From here, I'll select OK. And that brings up the parameters for the contour toolpath. So now we've selected the geometry to drive this tool path. Go to Tool. We're going to add a tool to the tool list. If I go to the project page and I scroll all the way to the bottom, we're instructed to use a 1/32 diameter ball mill, 0.03125 in diameter. It's going to have 2 flutes. Tool is going to be a C4 C4-0016, and tool projection is 0.5 inches. This is a very small tool, and the tool, you'll see it when we bring it in, but it's a very small, full radius tool. And we're going to use that to engrave our initials on the top of the part. So to add that tool to the tool list, I'll go to Select Library Tool. So I'm back in Mastercam, Select Library Tool. Now my filter is still active. So if I go to Filter, make sure it's checked, go to Filter. Start by selecting None to deselect all tool types. And then upper left corner, 2 from the left, it says End Mill to Sphere. Now, I don't like how Mastercam calls it that. People usually call them ball mills. So I'll select the End Mill to Sphere icon, where it says tool diameter. We're looking for a small tool, so I have it set to less than 0.125. It's only going to show me ball mills or sphere mills that are less than 0.125 in diameter. I'll select OK. And there are 3 to choose from. And the one I'm looking for is tool 301. It's a 0.03125 diameter ball mill. If I double click on it, it adds it to my tool list as tool number 3. To edit the tool, I'll right click on the tool. I'll select Edit Tool. And right away, I don't like the representation of it inside of Mastercam. Usually they're not nearly this long relative to the diameter. So let's set the overall length to 1. And then the shoulder length is 0.5. So the only thing I'm changing here is the overall length. Set that to 1 inch. And then select Next. The number of flutes, set this to 2. These tools will come with 2, 3, 4 or more flutes. You just need to figure out which tool you have available to you. So in this case, we were instructed to use a 2 flute 0.03125 ball mill. So number of flutes is set to 2. To calculate the RPM, you see what it says here? It says spindle speed 1,700, 100, 113. When I hit the calculator, watch what happens. It maxes out at 10,000 because we told it that the machine is only capable of doing 10,000 RPM. So that's what's going on here. If it was capable of more, it would calculate an RPM based off of the SFM, which we had set to 300. But the machine is only capable of 10,000 RPM, so it's going to max out. From here, we can turn on the coolant. I'll select Show More Options. I'll select Coolant. And then I'll set the flood coolant to on. And then I'll select OK. That'll complete all of the changes that I need to make on this page. From here, I'll select Finish. You can see that the RPM is set to 10,000 based off of the machine's capabilities. For the feed rate, let's set the FPT. Now, this is an end mill. This is going to be calculated differently than a drill. We need to think of it differently than a drill. For the FPT, set this equal to 1% of the tool diameter. So with drills, we've been using a 2% multiplier. Here, we're going to use a 1%. And these values will change depending on the material that you're cutting, the material that you're cutting with, and a lot of other variables that the cutting tool manufacturers will address. So here, I want to set my FPT equal to 1% of the tool diameter. The decimal equivalent is 0.03125 times 0.01, 1%. My feed rate is set to 6.25 inches per minute. This is a very small tool. We cannot feed it that fast. So 6 inches, 6.25 inches per minute. When it's moving in the XY plane, this is the feed rate that it's going to be using. When it's moving in the Z, I want to slow it down. I want to set it to half of the calculated feed rate. That's what I'll refer to this as, calculated feed rate. Set the plunge rate to half the calculated feed rate. What I'll do in this case is I'll type in the calculated feed rate, 6.25, and then I'll divide that by 2. So we're slowing down the feed rate when we're moving in the Z. From here, I've got rapid retract selected. And then in the comment field, I'm going to clear this out. I'll borrow the tool name. And then I'll provide some type of useful information. Now, anything that goes in the comment field, type it in all caps. We'll say engrave initials. That'll complete all of the changes that we need to make on this page. From here, I'll go to the holder. We're going to use a Cat 40 tool holder. So once again, I'll go to Open Library. CT40 inch. Open up that tool holder library. Now, if I go back to the project page and look at the tool list, it's saying a C4C4-0016. This is a Cat 40 tool holder. It's a collar tool holder, but this time it's an ER16 as opposed to an ER32. So we're looking for a C4C4-0016. It's a smaller collared tool holder. I think the range on this one maxes out at 3/8 of an inch in diameter. So here, set the tool projection to 0.5. And the diameter of the collet nut that I've got my cursor over is about 1 inch. So you get an idea of how small this end mill is. This end mill is 0.03125 in diameter. It is a very small diameter ball mill and easily broken. So we need to be careful with these. Tool projection is at the 0.5 inches. From here, I'll go to cut parameters. We're going to make several changes to the default settings. We're engraving with a contour toolpath. So the first thing that I want to do is I want to turn off the compensation type. So where it says compensation type, the default on mine is set to where, set yours to off. Contour type should be 2D. I'm going to jump down to stock to leave on walls, set this to 0. So changes that I made to this page. Compensation type is set to off. Contour type is 2D. Direction doesn't matter. We have it turned off. Stock to leave on walls is set to 0. Stock to leave on floors should be set to 0. From here, go to depth cuts. We're only going to engrave 5/1000s deep, so I'm going to turn depth cuts off. Uncheck it. You should see the red circle with the diagonal line going through it. Below that, lead in, lead out, or lead in /out. I want to turn this off, so uncheck it. You should see a red circle with the diagonal line going through it. Breakthrough, we're not using it, so make sure that it's unchecked. Multi-passes, once again, we're not using it, so make sure that it's unchecked. So you should see circles with diagonal lines for everything underneath cut parameters. From here, go to linking parameters. Let's activate the clearance. Set the clearance to 2 inches absolute. And I'm going to use clearance only at the start and the end of the operation, just like we did with the drilling operations. For the retract, we're going to do this a little bit differently. Turn on retract, set it to 0.1 absolute. For the feed plane, I'm going to set this to 0.05 incremental. Top of the stock, absolute. Remember where remember where our origin is at. Z0 is the top of our part, so I can pin 0 if you know, if you can remember what it is, or you can select the top of the stock icon and then go into the graphics area and pick select something that represents the top of the part or the surface that we're engraving on. And then for the depth, I'll set that to absolute. And once again, you can select the depth icon. You can pick select something that represents the surface that we're engraving or the top of the part. And then when the 0 populates this field, click next to it and type in -0.005. Now there's different ways we could have done that. This is just the easiest one to visualize at this time. So depth is -0.005 absolute. And that'll complete all of the changes that we need to make to this tool path. From here, I'll select OK. Doesn't look like much inside of, or the toolpath doesn't look like much inside of the graphics area. If I run it in backplot, so I'll select just that new contour toolpath. I'll select the backplot icon. And then I'm going to single step. If I zoom in, you can see that the tool is slightly into the material. And I'm just hitting the S key. And I'm watching the toolpath machine the initials. So I like what I see. I don't see anything that's causing a problem. I'll exit backplot. I can toggle off the visibility of that toolpath. I'll fit the screen. I'll unzoom 80%. And once again, before you run it and verify, it's a good idea to save your work. To run it and verify, I'm going to select the entire first operation toolpath group. And then I'll select the verify icon. Make sure stop condition collision is turned on. In this case, I'm going to turn up the precision. I'll slow it down a little bit, and then I'll select play. Once verify is done, I'm going to inspect the machined model. And when I zoom into my initials, you should see the wireframe geometry that represents my initials or represents your initials centered on the machined initials. Everything looks pretty good. I don't have any collisions. So from here, I'll exit verify. Once again, I'll look at my work from an isometric view. I'll fit the screen. I'll unzoom 80%. And this would be a good time for me to save my work.